Do you want to learn how you can write your mutations for your AppSync API? In this video, that is exactly what I'm going to teach you how to do. Hi guys, my name is Sam with Complete Coding, where our aim is to make you into the best AWS and serverless developers that you can be. In this video, we'll be looking at our AppSync mutations and the different ways that we can create them. The first way is very similar to how we've done a lot of our queries, which is using VTL templates. This is probably the easiest way, but also has a slightly more limited set of functionality. The second way is by using Lambda to resolve that, and in that Lambda we can then write to Dynamo, but we can also add some extra logic steps in for extra things that we might need to do. If you want to skip to just one part of that, in the description below are timestamps for each part of this video. So let's jump into our code and see how we can get this all set up. To start off, we actually need to define all of our mutations. So the place we're going to be starting is our GraphQL schema. And if we find the mutation section, which is coming from the main schema, we need to add a couple of mutations. So we need to be able to create a company. We need to be able to set the LinkedIn code, because when the user sets up a new company, then we need to get them to log in to that LinkedIn account so that we can post on that behalf. We then also want to create posts, update posts, and delete posts. And something similar with groups, where we want to create and update groups. For now, I've got rid of deleting groups, because if you delete a group that contains posts, what happens to all of those posts and how do you find them again? So for now, I'm just leaving that. In the future, we may add the ability to disable a group or something like that, but we can get onto that later. Finally, we have schedules, and again, we need to create, update, and delete schedules. And basically that is all of the mutations that we need right now for the front end through AppSync. So if we scroll back up to the top of these, we're first going to have a look at the create company one. So if we have a look inside Serverless and appsync.api.ts, we now have this section of mutations, and I've decided to use these square braces to basically have an array of the queries, and then I spread that array into the mapping templates. I can do this because these are just TypeScript arrays, so having an array that is spread into another array is perfectly fine, and it allows you to then minimize that section. So you can minimize queries, I could minimize all my mutations, and I've already minimized the nested fields, just to make things a little bit cleaner. So with the create company mutation, we need a type of mutation, field, create company, and this is going to be working on the companies table. This is going to be using a normal VTL template. So if we go into the mapping templates and go down to mutations, and then we find create company.request. This basically does a put item instead of a get item. The company ID, because we don't want them to provide it, we want to randomly generate it. We're going to be using util.autoid, which we'll see a couple more times in this video. So we also have the owner ID, the company name, and the company logo. The owner ID is going to be the identity of the requester, because if you create a company, you are currently the owner of it. As well as that, there is a company name and a possible company logo. The response for this is just a returning the context.result. And if we head over to our console and we look, instead of in queries, if we look inside the mutations and delete the query, in here we can get the create company and we can give this a name. So I'm going to say AppSync test company. And as well as that, if I scroll down, we can then get the company ID returned, as well as say the logo and the name, and let's say the LinkedIn access code as well. If we hit play, we get the create company response, and this is the randomly generated company ID with our company name, which I've obviously spelt with 2 Y's because I can't type properly. So that's the first and most simple way of doing a mutation, which is very similar to the ones that we've done previously. Next, if we look back into our GraphQL schema, we have the set LinkedIn code. Again, if we go into our appsync.api.d.ts, we have mutation set LinkedIn company code. And again, this is acting on the companies table again. In the mutations on the left, we can find that. So here we are. So this time, instead of it being a put item, I'll move this out of the way a little bit. It is an update item. And in here, we are doing an update where we're passing in the company ID, which has been provided, as the key, because that is how we are referencing this object. And then within that object, we went to pass in an update expression, which is just set LinkedIn code to equal the value of colon LinkedIn code, and then the values that go into that expression. So for us, colon LinkedIn code is context.argument.LinkedIn code. The last thing that we want to do is add a condition to this, because we only want to try and do this if the company ID that we're passing in here actually exists. If this doesn't exist, then this record doesn't exist, and we don't want to try and update a company that doesn't exist. That doesn't make much sense. As well as that, we have the response, which again is just context.result, and JSONify that. And that is how we can update them. So if we jump across into our console again and find set LinkedIn company, but first we're going to copy the company ID from the previous result. In here, we're going to pass in the company ID and then the code. I'm just going to manually type a random value of test code. And then from here, we're going to get the company ID, company name, LinkedIn code, and owner ID. So as we can see, we then get back the data with set LinkedIn company code. We have the test code. We have the owner ID, which is my ID, as you can see there. And that was generated in the original create of this company. We also have the company ID and the company name. So that means that we have successfully updated the LinkedIn code without doing anything else like overwriting the company name or anything like that. If we now head back to our code, we can look at how we can update some of the other mutations. If we were going to create our create post, it's going to look almost identical to the create company, except this time it's going to have some slightly different values. Update post we're going to get back to in a little minute, as we're going to be using a Lambda Resolver for that one. But first I want to show you delete post. This is going to be very simple. So if we go up to our mutations and find delete post, This one is a delete item on the post ID containing the post ID that's passed in. And again, there's the condition that it exists. So that is how we are going to be doing our deletes in most cases. But in somewhere like delete schema, we actually need to pass in the company ID and the schedule ID because this has a composite key for its primary key. So if we do go back to our GraphQL schema, we can go back to our update post, and this is going to use some slightly different methods for resolving. If we go into our AppSync API.t.ts and find our update post, this time we're doing something different. This time we set the data source to be update post function, and we set the request and response to be false. What this does is it means we don't need to create a VTL template, but if we look inside our data source, we need to define a function as a data source. The way that we do that is that we scroll all the way down to the bottom of our file. We have all of our tables, but then we also have a new thing here, which is called a data source of AWS Lambda. I've called this update post function, and all this does is references a function called update post. Coincidentally, inside source and functions, I've actually created a new file or a new folder called update post with an index.ts that contains all of the logic I need. I've created some types, so this is the types for the arguments that can get passed into this request, as well as the type of post, as this is going to be useful for returning things in the right format. If we go in, we can see that I get all of the parameters from the arguments. As we go down, we can then check if the post ID doesn't exist, return an error. And I've also said that if they haven't given us any text, a new group, a new publish time, or change the status of draft, then throw an error message, because we don't want to have to run any logic if they've not passed us any of the optional parameters. The next thing to do is actually get the original post. So in this case, we're going to be querying on process.post table. We're querying the post ID with the post ID that's been passed in. And here we're using a set of utilities that I've created, which makes querying Dynamo or getting items from Dynamo a little bit simpler. All that is if we go into libs and DynamoDB, I've created over time this set of functionality. So we have a get method, a write method, a delete method, and a query method. And the reason I do this is because this query takes, what is it? 7 optional parameters, and some of them are required. But if you actually look at the structure of this request, then actually trying to type all of this and memorize everything in the right format and the right way is actually quite a lot of work. And by creating this helper function, it massively simplifies the work I have to do every time I want to do a query. So that's just exported in the libs folder, and I import it into my functions. If I can't get the post, again, I throw another error. I then say this is going to be the updated content, where it's either going to be the content text that's been passed in, or the original text from the original post, depending on whether they've passed in any new text. And if I go down to the update post, I do something similar. I either use the OR operator or a ternary equation, basically to either keep the items and the values the same or use the passed in override. After all that, I just do a dynamo utils.write and return the updated post, which is going to be everything that is in here. With that Lambda, I also need to go into the functions.index.ts and add that to the functions. So I define where the handler is and then define the IAMROLE statement, saying that this is allowed to do a put and a get on the posts table, because that's the functionality we need and we don't want to give it access to more than it should have. If you don't remember, this is basically just an object of function configurations, which eventually gets imported into our serverless.ts as functions. And if we scroll all the way down, is substituted in here to define all of the functions in our serverless project. I do the same thing for quite a few of these. So if we go back to the GraphQL schema, we now know how update post works. And the reason I've done it with a Lambda instead of a VTL template is that if they only pass one of these in, then content text is going to be null. And I don't want to delete the existing text if they are only updating the group ID, or if they're changing it from a draft to not a draft, that will become false. These will be null, and I don't want to overwrite the existing values. I do the same process for create update group, again using a Lambda for the same reason. But when we get down to the schedules, there's a couple of little extra steps. So even with create schedule, we have to use a Lambda. And that's because if we go into the create schedule Lambda and we scroll down a little bit, we see here that we are setting the TTL. This time to live is when the schedule should next expire. This will automatically delete it out of the database. And if you remember the architecture, that will then trigger a Dynamo Streams, which will trigger Event Bridge and another Lambda, which is listening for any deletions on the schedule table. Because we never actually pass in the value for this, we only pass in a CRON schedule, we need to use this parser, which comes from the CRON parser, to turn the CRON schedule into a TTL time. It does this by working out the CRON expression, and then with .next, we are getting the next invocation of that. And then we are getting the time in milliseconds for that. So that's going to be the Unix time. And because the TTL needs to be in seconds, dividing that by 1,000. We then simply write that to Dynamo, and that's how our function works. We return the schedule, and that is the resolver for create schedule. Update schedule works basically the same as any of the other updates, where we check that the fields required are there. We make sure that they're updating at least one of the fields. And then when we go down to the CRON schedule, if they've passed in a new CRON schedule, we calculate a new TTL time. But if they've kept the schedule the same, then we just use the same schedule. Finally, we update that to Dynamo, and that is how we have all of our different resolvers for our mutations. In this video, we've looked at our AppSync mutations, and our different ways of resolving them. We've used both the VTL templates as well as Lambda Resolvers to be able to store the data inside our database. With all of this in place, we can now add data to our database as well as query that data. So in the next video, we're also going to be looking at how we can deal with having a user sign up and basically get ready for building our front end.